Welcome in Refrigeration and Air Conditioning lecture. Today we'll continue the topic, that is applications of refrigeration and air conditioning. So in that applications, in last lecture we already studied the domestic refrigeration application, that is domestic refrigerator, domestic air conditioning, in which we studied the window air conditioning and split air conditioning. Along with this, we also studied the automotive air conditioning system. So if you see, this is the basic applications of refrigeration and air conditioning, and in that applications you can see the vapor compression cycle is the basic cycle we used to run this refrigeration and air conditioning system. So the next application of this refrigeration is nothing but your evaporative cooler. We see the evaporative cooler, also evaporative air conditioner, you can call it as a, so is a device that cools air through the evaporation of water. Evaporative cooling differs from air conditioning system, which use vapor compression or absorption refrigeration cycle. So in air conditioning we studied that vapor compression or vapor absorption refrigeration cycle we are using. But evaporative cooler uses the fact that water will absorb a relatively large amount of heat in order to evaporate. That is, it has a large enthalpy of vaporization. So the temperature of dry air can be dropped significantly through the phase transition of liquid water to water vapor. This can cool air using much less energy than refrigeration. So in extremely dry climates, we are generally using this evaporative cooler, as the air has the added benefit of conditioning the air with more moistures for the comfort of feeling occupied. So if you see the basic working of this evaporative cooler, then how it works, that is, here you can see that evaporative pads are there, and in evaporative pads we are distributing the water, and when we spray this water on the evaporative pads, and this water is again collected at the bottom of this evaporative pad in a water reservoir. So whatever may be the hot air which is coming is passed through this evaporative pad, and this is served by the blower, and it becomes a cool because of the coming this hot air in contact with the water which is distributed on the evaporative pad. So this water becomes evaporated by taking the heat of the hot air, and this water becomes hot and this air become a cool, and this cooled air is passed to the place where we require the cooling effect. So this is the basic fundamental working of evaporative cooler. So in this evaporative cooler, if you see that the hot ambient air is nothing but your total dry air, and this when comes in contact with the water addition, then what happens, this wet surface porous media we are using, and then this becomes this hot ambient air or dry air becomes a cool air, that is the moist air. So here you can see that sensible heat and latent heat. So the total enthalpy remains same at the outlet, but you can see that the sensible heat increase in latent heat is there. So you can see that as the total enthalpy remains same, but there is increase in latent heat in evaporative cooler. So next application, that is the water cooler. If you see the water dispenser, also known as a water cooler, if it is used for cooling only, is a machine that cools up and dispenses water with the refrigeration unit. So in water cooler, what happens? The basic application to cool the water, and this water cooling is happen with the help of this refrigeration unit, is nothing but your vapor compression cycle. So if you see in water cooler, the basic fundamental cycle is nothing but your vapor compression cycle, and in that vapor compression cycle, so you can see the again the basic working is based on your four basic components, that is compressor, then condenser, then expansion valve, and evaporator. So low pressure, low temperature vapor refrigerant is sucked by the compressor, and after sucking this low pressure, low temperature refrigerant, compressor compresses it, and its temperature and pressure goes on increasing at the outlet of the compressor. This high temperature and this high pressure vapor refrigerant is then passed through the condenser. So in condenser, it rejects heats into the condenser, and this vapor refrigerant becomes liquid. And this liquid refrigerant after the condenser goes to the expansion device or expansion valve. And in expansion valve, after expansion valve, this liquid refrigerant, part of liquid refrigerant is converted into the vapor, and we are getting liquid plus vapor refrigerant at the outlet of the expansion device. And this liquid plus vapor refrigerant then goes to the evaporator, where we require the cooling effect. So in that cooling effect, where we require cooling effect is we are placing the evaporator, and in evaporator it takes heats from the place where we require cooling effect, and this liquid plus vapor refrigerant is totally converted into the vapor form. And this vapor refrigerant then goes to the inlet of the compressor. And again at the inlet of the compressor sucks this low pressure, low temperature refrigerant, and again it compresses, and the cycle is continuously working by rejecting heat into the condenser and taking heat into the evaporator, where we require the cooling effect, and this we are cooling this water into the water cooler. So the same vapor compression refrigeration cycle we are using into the water cooler applications also. So if you see in applications of evaporative cooler and in applications of water cooler, the basic difference is that we are using the vapor compression cycle in water cooler, while in evaporative cooler you can see that there is no refrigeration cycle, no refrigeration unit we are using. In evaporative cooler only we are using a blower and a small pump we are using for distributing the water into the pad, and we are using this pad for distributing the water, and whatever may be the hot air coming is passed through this pad, and it becomes cool by taking the moistures or by taking the moistures from the water which is distributed on the pad, and this cold air, moist air, is then circulated where we require the cooling effect or the cold air. So that is the basic difference between the evaporative cooler and the water cooler, as we are using the basic vapor compression cycle in a water cooler. In that we are using compressor, condenser, expansion device, and the evaporator. These are the four basic components, while these four basic components are absent in the evaporative cooler, as it is we consider that there is no compressor we are using, there is no condenser we are using into the evaporative cooler, and in that case, so the difference here you can measure that the power required to run the compressor is more in case of your water cooler, and While in case of evaporative cooler, only we are using a small pump for circulating the water, which distributes the water into the evaporative pad, and the remaining parts are absent, remaining components are absent into the evaporative cooler. So these are the applications. So if you have any doubt related to these two applications, that is evaporative cooler and water cooler, you can contact on this phone number. Thank you.